Hello children, today we will be discussing a very important topic, and that is atomic structure. Now the concept of atom, as you all know, was proposed by Maharishi Kanad, and then it was forwarded by Democritus, the Greek philosopher, who gave it the name atom, and atomos means indivisible. But later on it was found that atom is not indivisible. It has subatomic particles, that is protons, electrons and neutrons. Then a lot of work was done by J.J. Thomson, Rutherford, Niels Bohr to figure out how these subatomic particles are arranged in an atom. And finally, the modern model of atom clearly depicts or displays the arrangement of these subatomic particles. Now, as you can see in this modern atomic model, the protons represented as P plus and neutrons represented as N0 occupy the nucleus of the atom. The nucleus is the central core of the atom and it has a positive charge. We know that protons are positively charged and neutrons have no charge. So both of them together are present in the nucleus, and the nucleus gets its charge from the protons. The protons and neutrons together are known as nucleons because they are present inside the nucleus. The nucleus is the positively charged core or center of the atom. The extranuclear region is mostly empty because here what are present? Electrons, which are far away from each other and moving in fixed orbits or energy levels or shells. So the atom consists of a nuclear region having the nucleons, that is protons and neutrons. It consists of an extranuclear region which has orbits or shells or energy levels, which are the paths. The atom doesn't have rings like this. These rings just depict the path along which electrons are moving. To symbolize an electron, we use the symbol E minus. So P plus for protons, N0 for neutrons and E minus for electrons, because protons have a unit positive charge, electrons have a unit negative charge and neutrons are neutral. So 0 means no charge. Now these electrons are arranged in these energy levels or orbits or shells. Why are they called energy levels? Because the electrons move in them or on these paths according to the energy they have. The closer the shell is towards the nucleus, lesser would be the energy. As we move from inner to outer levels, energy levels increase. The first shell is called the K shell, followed by next L, then M, N and so on. At your level, we only need to be aware of these four shells, K, L, M and N. Since the K shell is closest to the nucleus, we give it the shell number small n, that is 1. L shell is given the shell number 2. M is given the shell number 3 and N is given the number 4. So as we move away from the nucleus, the number increases. K is 1, L is 2, M is 3 and N is 4. Now the question arose that how are these electrons arranged in these energy levels or shells? And there was a lot of controversy regarding this. But finally Bohr and Bury came up with the Bohr-Bury rule or Bohr-Bury scheme. These set of rules helped everybody to understand the filling of electrons in these shells. These rules had 3 points. First one, the first rule said that electrons are filled in these energy levels or shells by the formula 2n square. 2n square, where n is the shell number. So like if I have to work out for K shell, what is the shell number for K shell? N is 1. So how many electrons can the K shell accommodate? 2 into 1 square, which is what? 2. So maximum number of electrons which K shell can accommodate is what? 2. Then comes the next shell, that is L shell. What is the shell number of L shell? It is 2. So 2 into 2 square, 2 square is 4 and 4 into 2 is what? 8. So L shell can accommodate how many electrons? 8. Maximum. It can accommodate maximum 2 electrons. This can accommodate maximum 8 electrons. Next comes the M shell, whose shell number is 3. So 2n square would be 2 into 3 square, that is 3 square is 3 3s are 9 and 9 2s are 18. So maximum number of electrons which the third shell can accommodate is what? 18. And finally we come to the fourth shell where n is 4. So in the n shell, 2 into 4 square is 16 and 16 2s are 32. So if you are asked to work out how many electrons maximum can be accommodated in K, L, M and N, you have to show the working and then write the answer. So K shell according to the 2n square rule can accommodate maximum 2 electrons. L shell can accommodate maximum 8. The L shell, M will accommodate maximum 18 and N will accommodate maximum 32 electrons. This was the first rule proposed by Bohr and Bari, the first point. The second rule or the second point is proposed by them that these electrons have to be filled in a stepwise manner. Stepwise means first electrons have to be filled in K shell. Once K shell gets filled, then it will go to L shell. Once that gets filled, it will go to M shell. Though this rule has a lot of exceptions also, later on it was found. But this was the second point, that electrons have to be filled in a stepwise manner. But third rule was slightly different. It said that outermost shell, no matter which one is the outermost, maybe K is there, L, M, N. So if pertaining to L, M, N, outermost shell of an electron can never have more than 8 electrons. That means even if the outermost shell is M and it is capable of having 18 electrons, then also if it is outermost, it cannot have more than 8 electrons. We will do some examples for you to understand better. So according to the Bohr-Bari rule, 2n square formula is used for finding out the maximum capacity of every energy level or shell. Then the electrons need to be filled in a stepwise manner. And thirdly, the last shell cannot have more than 8 electrons. So before we discuss any examples or how to calculate the number of protons, neutrons or filling of electrons, we need to be acquainted with two terms which we would be using often, that is atomic number and mass number. Now, atomic number is the number of protons which are present inside the nucleus of an atom, that is its atomic number, and it is denoted by the letter Z, capital Z. Mass number is the number of nucleons present inside the nucleus of an atom. Nucleons means neutrons plus protons. So number of protons is the atomic number depicted by letter Z, and number of nucleons, that is sum total of protons and neutrons, is known as the mass number, and it is denoted by capital A. Whenever we have to show a symbolic representation of any element, say element X may be sodium or chlorine or magnesium, any element, X means any. How do we represent it? We write the mass number on the top and the atomic number at the base. Sometimes we may also write A on this side and Z on this side, both are correct, but we will follow this system, both a mass number and atomic number on the same side. Remember, atomic number is represented by Z and mass number by A. You often get confused and think that since atomic is beginning with A, so this would be A, so it's reverse. So what is written here? The mass number, and here what? Atomic number. Now I told you atomic number is what? Protons plus neutrons, and the mass number is what? Protons plus neutrons, and atomic number is what? Number of protons. So if I have to calculate number of neutrons, tell me how will I calculate? That is, I am repeating, mass number is what? Protons plus neutrons, and atomic number is what? The number of protons. If I have to calculate number of neutrons, what will I do? I'll simply do A minus Z. That is protons plus neutrons minus protons. What are you left with? Neutrons. So when I need to know the number of neutrons, I have to subtract it. Now if I know the number of protons, how can I calculate the number of electrons? You know that an atom is electrically neutral. That means total number of protons is equal to total number of electrons. That is why it is neutral. Neutrons are not contributing to any charge. So if you know the atomic number, you know the number of protons, and if you know the number of protons, you know the number of electrons. So we come to the conclusion Z is equal to P plus is equal to E minus. That is, atomic number is same as number of protons, which is same as number of electrons. That means if I give you the symbolic representation of any element, you should be able to give me what all information? Seeing this, you should be able to tell me what is the atomic number, what is the mass number, what is the number of protons, what is the number of electrons, and what is the number of neutrons. From this symbol only you will be able to give me all this information. Let's see how. We will do some examples for you to understand, and we also need to learn how these electrons are arranged. So when you draw this complete structure of the atom, it is called geometric representation. And when you write the arrangement of electrons, we call it electronic configuration. So today we learn how to write the electronic configuration and how to depict or show the geometric representation. If you have noticed, on the right hand side there is a list of 20 elements. Please go through them. You will find them in your book also, and you have to learn these elements in the same order. All these 20 have to be learned by you in the same order. In front of every name, the symbolic representation has been shown, if you have noticed. The first example is hydrogen. If we take the example of hydrogen, from its symbolic representation, you have to find out whatever information it is giving you. H11. Now what is this? This is the mass number represented by A. So A is how much? 1. This is what? The atomic number. Z is also how much? 1. Now if I have to calculate the number of protons, what is number of protons equal to? It is equal to the atomic number, so it is also equal to 1. If I have to calculate the number of neutrons, what do I do? A minus Z. Follow the steps. A minus Z. This is A and this is Z. That means 1 minus 1. So how many neutrons you get? 0. If I have to calculate number of electrons, how will I calculate? Electrons is equal to protons. And how many will you get? 1. So its atomic number is 1, mass number is 1, 1 proton is present, 1 electron is present, and neutron present is what? 0. Now how would this electron be arranged? How many shells will hydrogen have? Only 1 shell, because 1 electron, electrons have to be filled in the stepwise manner. So first where will they occupy? The K shell, 1 electron. So we write the electronic configuration, EC. And what is the electronic configuration? 1. Now if I have to draw its or show its geometric representation, how will I show it? First I will make a nucleus. In that nucleus I will write 1 P plus. That means it has 1 proton. 0 N 0. That means it has no neutrons. If you don't write neutrons, that is also okay, but it's better that you show that it is 0. So nucleons will always be represented first. After that you will draw the energy level. How many shells will it have? Only 1. I am drawing it freehand. You will use a compass and draw. And you will draw simply one shaded circle here, which is representing what? Electrons. We don't write E here. It is understood that this is an electron. And under it you will write the symbolic representation. Now this is how you are going to do the work in your copies for all 20 elements. We are going to do some of them as examples and remaining you will have to do on your own. This work will be done on the ruled side and this work would be done on the plain side of your interleaved copy. For one element, half a page is more than enough. So 2 elements can be done on 1 page. So you will write hydrogen, write its symbol here, show this working here in the same order, okay, and then draw this on the left side with the symbolic representation. Let's do the second representative here. So we can skip helium. Helium you can manage on your own. If you take a look at helium, it is He42. Now in He42, what is the mass number? Mass number is what? 4 and atomic number is what? 2. So how many protons is it having? 2. How many neutrons? 4 minus 2, that is 2. How many electrons? 2, because protons is 2. Your mass number, atomic number are clear here. I hope you are able to calculate the number of protons, electrons and neutrons. And what will be the electronic configuration here? Only 2. The first number means K shell, so you don't have to write K here, only number 2. So K shell with only, and when you draw with this electron you will draw one more electron. So you can draw electrons in pairs when you draw them, so make one more electron here with this pair. You may draw it on the other side, but it's better that you draw it in a pair. We will do the third element now, and that you can see in the list is what? Lithium. So third element is lithium 3, 7. This is the mass number, this is the atomic number. So now A is what here? 7, and what is Z? 3. Number of protons is written at the base only, how much? 3. For calculating neutrons, what do we have to do? 7 minus 3, which is how much? 4. 7 minus 3, which is 4. Electrons is same as protons, please follow the same sequence. What do you get here? 3. Now what will be the electronic configuration here? 2 will be filled here and remaining 1 would go to the L shell. So how will we write it? 2, 1. This is the electronic configuration. Now reason why I am saying you write this in the same order. You could have done protons is equal to Z is equal to electrons is 3. But there was no need for this step here. You could have done electrons here only. But when we write electronic configuration, number of electrons should be written just above it. Otherwise you might go wrong, because number of neutrons is 4. Now this is a very common mistake which many of you make. If this 4 is written here, neutron is the last calculation you made. What do you write here immediately? 2, 2. You forget that electrons are 3. You start operating using the word, using the number 4. Okay, so be alert, follow the same sequence in your copy. We are doing what? Lithium. Now how are we going to draw for lithium? How many protons does it have? You have calculated it just now. See, this is what? 3p plus. And how many neutrons are there? 4 and 0. 3 protons, 4 neutrons. This is the nucleus. Now how many shells are there? 2. So make one more shell here. Okay. And in this shell, first in the first shell you will fill 2 electrons, and then in the outer shell at any place, it's better that you prefer these corners, okay, these end poles. Here only 1 electron, 2, 1. You don't have to write K shell, L shell, it is understood. In the configuration also it is understood, in the geometric representation. And under it you will write what? Li73. Now this work, written work on the ruled side and this on the plain side. Do all the 20 elements in the correct sequence, 2 on 1 page. Total on 10 pages you would be doing your work. Again we will skip some and let's come to nitrogen. Okay, others you can manage in the same order. Okay, for nitrogen it's 14, 7. So what is A here? 14. What is Z here? 7. Protons is equal to Z, and that is what? 7. Neutrons is A minus Z, okay, that is 14 minus 7, which is also 7. Remember, it might be a coincidence that neutron is same as proton, or it may be different. It's not necessary that they would be same or they would be different. You will keep finding lot of variation here. So here neutron is also 7, and proton is equal to electron, which is what? Or we write electron is equal to the number of protons, which is what? 7. And how do we write the electronic configuration here? 7 electrons have to be filled. 2 will go to the K shell, and how many are left? 5, because L shell can be filled till 8. So 2 and 5 is our electronic configuration. How will you draw this? Inside the nucleus, okay. What will you draw inside the nucleus? First you write protons and then neutrons. 7 protons, 7 neutrons. So 7p plus 7n0. How many shells? 2. 1, 2. How many electrons here? 2. And here we discussed 5. 2 here, 2 together in a pair here, and 1 anywhere else, this side or that side. This is the geometric representation of nitrogen, and here you write N14, 7. So I hope you have understood for these elements. So till 10th, I think it must be clear to you. Here configuration is 1, here it is 2, here it is 2, 1. For number 4 it is what? 2, 2. For number 5 it will be 2, 3. For number 6 it will be 2, 4. For 7, 2, 5 like we did here. For 8, 2, 6. For fluorine, 2, 7. And for neon, 2, 8. So the outermost octet is filled. It is called the octet rule. That is, if the last an atom has more than one shell and the last shell has 8 electrons, it follows the octet rule. That is, all 8 electrons are there, it is complete, it's stable. If only K shell is there and it has 2 electrons, it is filled, like in case of helium, okay, it follows the Duple rule. Duple means 2, it can accommodate only 2 and it is filled. So if you have noticed, helium is an inert gas and so is neon. This is following the Duple rule, this is following the octet rule. So that is why they are stable, they are inert in nature. They don't need to give any electrons, they don't need to take any electrons, because whenever an atom is unstable, it needs to donate electrons or accept. Both of them are inert gases, non-reactive in nature, neither they give electrons nor they accept. So here this is following the Duple rule and this is following the octet rule. So I think 1 to 10 is clear. We will do some examples from the other side, and remaining I am sure you will manage on your own. Okay, so let's choose one from there. We can choose first sodium. First one, that is Na2311. So what is the atomic number and the mass number? Atomic number is 11 and mass number is 23. Protons would also be 11, neutrons would be 23 minus 11, and that is what? 12. 23 minus 11, that is 12. Electrons would be how much? 11. Again I will remind you, write electrons here. If you calculate protons here, you would be using 12 to figure out the electronic configuration. So electron should be the last thing what you write here. And what would be the configuration? 2 of course is same. 2, 8. 2, 9 would be wrong, because what is the maximum number of electrons in the second shell? 8. So you can't do it 2, 9 because it's 11. 2, 8, 1. So when we will draw the shells for your sodium, we would be drawing 3 shells here instead of 2. Here space is less, so I am making it close by, you make it a bit far, okay. 3 shells would be shown here. The nucleus would have protons and neutrons. Now how many protons? In this case 11p plus. How many neutrons? 12 and 0. And how would the electrons be arranged? The K shell would have 2 electrons. The second shell would have all 8. So you can draw them in 4 pairs. And the last shell, that is the M shell, would have only 1 electron, shown here 281. So for sodium it is 281. For magnesium, what would it be? Magnesium is what? At number 12. 282. For aluminium, 283. For silicon, 284. Likewise you draw also here. Okay. For phosphorus, number 15. 285. For sulfur, 286. You will do all this working in the same manner and write the configuration as 286 and draw 3 shells, fill 2 here, 8 here and then 6 here. Chlorine, 287, and then again comes an inert gas, that is argon, 288, whose outermost shell is following the octet rule, 288. Now exception again begins where? In the last 2, that is potassium and calcium. What is happening here? Now potassium is K1939. Let's do the working for potassium. So mass number is 39, atomic number is 19, protons also 19, and neutrons is 39 minus 19, that is 20, and electrons is again 19. What will the configuration be? 2 electrons in the K shell. L shell would have 8 electrons. I hope it is clear till here. 2 plus 8, 10. How many are left? 9. Technically, the third shell is capable of accommodating 18 electrons. So all those 9 electrons could have gone in the third shell. But what did the third rule say? That the outermost shell cannot have more than 8 electrons. So this rule applies here. If it cannot have, and it is the outermost shell, it cannot have 9. So 289 is wrong. Where will that 1 electron go? To the 4th shell. So now we have 4 shells. So this will be what? 2, 8, 8, that is 2 plus 8, 10, again 8, 18, 1. And when you draw it inside the nucleus, you will be writing what? 19p plus 20n0 inside the nucleus, drawing 4 shells in the first shell and keep them equidistant. Use a compass and a sharpened pencil. 2 in the K shell, then next shell 8, then again 8, and only 1 in the last shell. So you have to remember, potassium is not 289, it is 2881, and I am sure you will be able to draw its geometric representation. And likewise for calcium, can you guess what will be the situation? How many electrons? 20. So how would we represent calcium in the electronic configuration first? It will be 2882. And while drawing, again you will draw the nucleus, fill the protons and neutrons in it. And how will the electronic configuration be shown? First 2, then 8, then 8, and then what for calcium? 2. So I hope now you know how to, from a symbolic representation, how to calculate the mass number, the atomic number, the number of protons, electrons, neutrons, and how to write the electronic configuration and how to draw the geometric representation. So keep practicing for all these 20 elements, learn their mass number and atomic number, and once you get the hang of it, it will be very easy. You will be able to solve it very easily and very quickly. Okay children, thank you.